Let's go ahead and get started on the shake method. So the idea behind shake is we're gonna basically, it's kind of like mix these numbers up, jumble them up, and make sure that they are, well, we're gonna keep jumbling them until we get every row and every column, every diagonal to be the same total. So you can imagine it's going to take a lot of tries. In fact, in this particular example, it took 31,230 tries or 31,230 jumblings to get, to where what we want, which is the total of 15 for each row, each column, and each diagonal. Now, the tricky part here is, yeah, we can jumble them up. We know how to do random generators, but we got to make sure that we don't get duplicates. So in this particular case, our max is 9, min is 1. We can randomize all these. We just got to make sure that they are not repeated. So let's take a look at what that looks like. I'm going to create the shake over here. Well, as a matter of fact, I will do the shake after the toString. And this is going to be a void. Okay, I know that I'm going to need a random. So I'll go ahead and get the package for random. Okay. Now I'm going to declare that. And I'm going to start with my max num. The max num is 9 for a 3 by 3, which means it's n times n, or n square. So I need to determine that right off the bat, n times n. And I'm also going to have a counter, and you'll see why in a minute. Okay. And just for the sake of this class or this tutorial, I'm going to be jumbling up each one of these: single array or single dimensional array, two-dimensional array, and the array list. Okay. And I found an algorithm that does this for us. It goes something like this. Okay. Now I'm going to come up with a random index to swap. Random index to swap. Remember, this is just an integer. It's just a number. I don't know what it is. It's going to be completely random. I'm going to call upon the rand, and whatever that random integer is, I want it to be anything less than the length of this one dimension. And remember, the one dimension is just straight from 1 all the way to 9. So that's going to be 9. And I'll just say 1dim.length. If you remember when we printed it out before in the print me, the one dimension just goes from left to right, 1 to 9. Okay. So I need that length. And now I need a temp. And I will take the one dimension at this index that I just generated. Swap it. So this temp will take on whatever value is inside here. Okay. Oh, it looks like I need to get rid of these. Oh, right. I will in fact change this out real quick. Okay. Really, all of these will be in the loop, actually. Okay. So I need my temp to be whatever value is in this random index. And I'm going to swap it out. So the temp is going to swap it with the original wherever I is, and it'll look something like this. One dimension at index I is going to take whatever temp is. And that's all there is to it as far as the one dimension. It's a really efficient algorithm, one that I'm glad I found and I'm glad I saw, because usually what they would do to get rid of the duplicates is just that. They would actually have you get all the random numbers in there, whether they're duplicates or not, and check for duplicates, remove them, and then roll a new random generator. But this one, it's more intuitive, I would say. Okay. And now I'm going to use this same loop to set my list. Index to swap. I'm going to swap, or rather I'm going to set whatever value is in my array list at this particular index. And I'm going to swap it. So I'm going to swap this, or I'm going to set wherever this position is with this value. Okay. And I'm going to do it one more time. And it's basically the same thing as this. So what I'm doing here is I'm doing a swap for the one-dimensional array. And here I'm doing the exact same thing, or the same concept, just with the array list. I temp. Okay. And looks like I'm missing a semicolon there. Okay. So now that I have these ready to go, and keep in mind, this is an algorithm that's well known to get rid of any duplicates whenever you have a random generator. So if you do want to dissect this, I can actually start another video on this. But for now, I'm going to take whatever I have here, and I want it to match my two-dimensional array. So I'm not gonna reinvent the wheel, so to speak, for the two-dimensional array. Whatever values that I get in here, I'm just going to set it to my two-dimensional array. Okay. Oops. All right, now I have my 2dim. I'll take the I, I'll take the J, and this is where the count comes into play. I'm literally going to start from index 0 of the one dimension, start at index 0, go all the way to the very end, and just keep sticking the numbers in. Index 0, 1, 2, and then here and here, here. So whatever numbers are in the one dimension array, I'm going to stick them into the two-dimensional array, just like so. 1dim count at that index. So count is going to start at 0, over here 0, and I'll just keep accumulating it every time it comes into this loop. Okay. So let's go ahead and test this out. And this is a shake. Shake. Go ahead and print it out again. Now that I know these work, I can actually comment them out. And just to make sure, I'll just print the diagonals to make sure the totals work for that as well. Okay, here we go. Ooh. So it looks like I might have made a mistake somewhere because I've got duplicates. Well, that's no good. Although they are matching, I've got 3 3s, 988, 893. So 333, 988, 893. And it looks like the diagonals are adding correctly. Yep. Okay. So I'm going to have to troubleshoot and figure out where I messed up. Let's go back in the code. Here in shake, let's see. It looks like, I forgot to do a swap. Yep, I forgot to do one little swap here. One dim, of course, at the random index 2 swap is equal to 1 dim at I. Here we go. I do apologize for that. Okay. Let's go back in. Much better. So I originally start with 1 to 9. Now I've got 1 to 9 still, but jumbled up. 1, 2, 3, 4, 5, 6, 7, 8, 9. No duplicates. Perfect. And in the 1 dim, it looks like this. Arrayless, it looks like this. And we can make sure in the 2 dim, it looks like this. 738, 738, 496, 496, 521, 521. Excellent. So now that we have our shake, so we can just keep doing this shake until we meet this criteria where everything equals to each other. So all the rows and all the columns and all the diagonals equal to the same number, then we're going to return the number of times it took to shake, or number of shakes we did, and give us the sum. All right, so let's get back in here. So we're essentially done with all the methods now. We can go back into our client and we'll come up with the logic. And the logic, let's see, it says here, have a method to solve a 3x3 and another method to solve a 4x4. All right, so we won't be needing any of these. Instead, I'm going to ask the user, what do you want? Do you want a 3x3 or do you want a 4x4? So I'm going to need to get the scanner class. And let's go ahead and get our scanner object in. Whatever n is, new scanner, system.n. Okay. Enter a value for n. And it's going to take whatever you entered. Okay. Change that. And here I'll simply have an if statement. If n is equal to 3, let's call this function a 3x3. or this method, I should say. 3 by 3. I'll take the argument of object n, and let's go with that for now. So we're just going to have to create this method like so. Class. Oh, I'm sorry. It's going to be inside here, actually. Static void 3 by 3. And I'm passing in an object of type nxnbkt. So nxnbkt. And this one, I'll simply call it my object. Okay. Now, we know that this is going to take multiple tries. In fact, we don't know how many tries. So it's indeterministic and therefore a while loop. Okay. And we can use a do while loop if you wish, but I'm going to use a while loop using a sentinel or a flag to control when it does get kicked out of the loop. So here, I have my flag set to 0. It's kind of like a switch. And I'm going to need a counter of some kind to count how many tries it took. So I'll have a count equal to 0. So let's go ahead and enter this loop. While flag equals 0, which it already is. So it's going to be forced to enter at least once. And in this case, since this is only going to be a 3 by 3, I can set my n equal to 3. In fact, since the n is equal to 3, I can put it outside here. Okay. Now I'm going to need to find out, just pick any one method to find what the number is. And that's going to be our baseline to check against everything else. So I'm going to use one of the diagonals, since it doesn't have any arguments. I will say int my sum is equal to, I'll take my object and I'll say add diagonal 1. It doesn't really matter which you choose. So whatever number gets added up, let's say it's 15. 15 is going to be my sum. And I'm going to take all the other rows and columns and the other diagonal and check it against my sum. And like I said earlier in the previous video, I'm going to be doing a dynamic way. So even though it does say 3 by 3, any number will fit if you use this logic. Of course, you'd have to let n be dynamic as well. But I'll be using loops to basically iterate through all the columns and all the rows. Okay. And I'll be using another flag, and this time I'll call it just a signal of some sort, just to let me know, hey, there's something going on here. If something goes, if a particular condition is met, I want to know, and I want a signal to be turned on. So let's call this my signal. And you can call it whatever you want. So once I enter this loop, I have a baseline number to compare with. I have a signal that is set to 0, and I want to set it to 1 when I see something happen. And I also need to jumble up the numbers. Okay. And it's every time we do jumble up the numbers, we want to add a count or add to our counter. Okay. So first, let's take care of the rows. So I'm going to have a for loop to take care of the rows. Get me the total of each row. And now I'm going to check against the baseline, which is my sum. So if my object add row at index I, if is not equal to my sum, then I want to know. So tell me when it's not equal, and I'll set this to 1. Okay. So if all goes well, it won't even enter this if statement. My signal will still stay off or at 0. But if it is, then I want to know, set this to 1, and I'll be able to use it later. And now I'm going to do the same thing for the column. In fact, it's going to be the exact same code, just with column. Copy that. Here it'll say column. So if column, any of these columns are not equal to whatever my sum is, send me a signal so I can handle it. And then finally, if my object dot add die2 is not equal to my sum, same thing, I want to know my signal equal to 1. So now we've got 3 things to check against. And as part of the game, we need everything to be equal. So if one of them is not equal, then the whole thing is wrong, which is why I can just use one signal. Okay. So I could simply say, if my signal is, well, I could say if it's not equal to 1, or if it is equal to 1, whichever you want, but I'm going to use a not equal. So as long as it's not equal to 1, meaning it's still turned off, it never entered here, never entered here, never entered here, that means everything is equal. So if my signal is not equal to 1, that means we found a match. We found a winning combination of numbers. And all we got to do is print this. So we can do system.out.print. Oh, wait, in fact, I want to be able to print the number itself, well, the number combination first. So I'm going to do my object.print me. So I'm going to print the whole thing. And then I'll do a system out. And I'll say my name got it. So BKT got it. I'll say count tries. And the sum equals whatever the sum is. And the sum, I actually have it right here, my sum. Okay. And that should take care of that. And the only thing left to do is to get us out of this loop. So if this is true, and I'm able to print this out, let's go ahead and kick us out of this loop. So I'll just simply set my flag to 1. That way, once it checks that this is 1, it goes back up the loop. It sees, oh, flag is not 0, kick me out. Okay, so let's go ahead and test this out. Enter an N, I will say 3, and there we go. In this particular case, it took 93,000 tries. And you'll notice that the sum is always 15. And that is because our max is 9. So no matter how you rearrange it, we need everything to be equal 15 in order for this to work. And let's double check. So we've got 8, 3, yep, that is 15. Yeah, that's 15. 15. Yep. Okay, looks great. But no buts. Yeah, so that's good. So that takes care of 3 by 3. And let's very quickly finish up the 4 by 4. And I'll do else if n equals to 4, then we'll do 4 by 4 obj. Okay. And of course, 4 by 4 has not been created yet. And this one will have a little bit more fun with it by hard coding everything. Okay. Static void 4 by 4. I'll be passing an object similar to the other one. xn bkt, my object. Okay. Similarly, I'm going to have the same concept. I'm going to need a loop, indeterministic loop. And I'll use a flag as usual. And I'm going to need a count as usual as well. So let's go ahead and start our loop similar to before. First thing I'm going to do is start a shake. And every time we do, accumulate the count. And let's have the same my sum equals to my object dot, let's take add type 1 again. And this time, we could use the same logic as this, and you're more than welcome to, but I'm going to go ahead and show you the hard coding way of doing it. So since it is only going to be 4, then we can adopt a different method, albeit, in my opinion, a less efficient method, but still works. So we're just going to go one by one and check if this is equal to this, and is equal to this, and is equal to this, and this, and this, and this, and this, then print this out. So it may seem a little tedious, but it'll work. Okay. So the first thing we got to do is just isolate all the possible cases. My object dot add row index 0 if it is equal to my sum, and my object dot add row at index 1 is equal to my sum, and I'm going to tab it there. We've only got 2 other possibilities. Since we're dealing with 4, we have 0, 1, 2, 3. So 0, 1, 2, and a 3. Okay. And I will close this here so I can separate the rows from the columns. And in fact, I'll do another one here. My object dot add column at index 0 is equal to my sum, and my object dot add column at 1 is equal to my sum, and same thing, simply make a copy of that. Zero, 1, 2, and a 3. So if this is all true, and don't forget, we've got the diagonals to worry about. I'll do it here. And my object dot add diagonal 1, if that is equal to the diagonal 2, object dot add diagonal 2. Okay. So I'll close that. Now I just need to close everything. I'll encapsulate this whole if statement like so. So if this is all true, then I can do this. I'll just copy that top one, paste it in, and that should do it. Now keep in mind, as soon as you just increase the n by 1, and now we've got 4, the chances of it finding a combination that actually works, it's much slimmer than if it was 3 by 3. So when you run this, it may actually take a few minutes, depending on, the randomness of it. The fastest I've got was, I'd say, like 40 seconds, but the longest I've got was 40 minutes. So I will actually compile this and I'll show you. I will try this for n of 4, and you'll see that it's still thinking. And I'll go ahead and pull up an example of what it should look like. And I believe it was this one here. This was a compile that I did before. The longest, so 39 minutes it took. And look at the number of tries. That's a huge number to find this combination where all the rows and all the columns and all the diagonals added up to 34. And yes, 34 is the number. Oh, here we go. So you saw it happen here. It took much lesser than 39 minutes. So it looks like we got lucky. And let's double check this to make sure. Got 13, 15, okay, 6. Excellent. 34. Let's just take a diagonal. If I took, okay. It's also 18, 19, 20, 34. Yep. So it looks like this works out. It's all 34. And again, when you run this, it may take longer than this. But on average, yeah, it should take like I'd say a minute to 5 minutes is what I've been getting most. But don't be surprised if it took longer, like in this case, 39 minutes. So now that we have this, we can go ahead and clean it up so that it only prints this the way you want it, is just a square without these guys. So all we got to do is go in here and we can actually comment these guys out. I would keep them just in case if we want to do more testing. And comment this to them out. So this would just leave you with the square. And I don't think you even need this new line. So let's test it out with a 3 by 3. And there you go. So I'll let you have fun with this. And I'll have the source code posted in my GitHub. Thank you very much for your patience and good luck.